Okay, there we go. Okay, section 3.4 is about bisection. Okay. We have already talked about this somewhat. We've talked about bisecting it. We learned how to bisect both a line segment and a angle back when we were looking at drawing with our compass and our protractor. No, well, you can do it with protractor and straight edge. Okay, you can just draw one, or you can do it with your compass and straight edge. So we've talked about how to do both. Okay, so in this 3.4 is bisecting. Somebody tell me what it means to bisect something, an angle or a ray. Yes.
It just means to cut it in half.
Yes, it's cut it in half. And we have learned so far to do the line and the ray. I should say line segment and a ray. You cannot cut a line in half. You can only cut a line segment in half, and then you can cut a ray in half. Okay, so those are the two that we have used. Both ways are okay. The old-fashioned way was with a compass and a straight edge. Okay. The new way, most of the time we do, is with a straight edge and a protractor. So we can do it manually, or we can do it with a measurement device that we already have, okay? The compass is just where you make those arcs above and below, so that's how we did that, okay? When we're doing this, when we cut a line segment in half, we get what's called a midpoint. The midpoint of a line segment is a point exactly in the middle of the two endpoints. So it basically says you're starting with a line segment, because I said it's of the line segment. So we start with a line segment. We find the point that is exactly in the middle of the two endpoints, and that's what is called a midpoint. Okay, so a midpoint is always the point exactly in the middle. It kind of tells you what it is. Point in the middle. Midpoint. Okay, it makes sense. And so that's what they're acting there. Okay. When we're doing a ray, we are actually the ray that bisects. There is no set. Is a ray directly between the two rays of the angle. There is no special name for it, like we have a midpoint for our line. There is nothing that really says that it bisects the angle, except for we know that we can say the word bisects the angle. That's all we can say. Now, if we have a line segment, and we find its midpoint, so say this is AB, and we cut it with C. C is our midpoint. What do I know about the length from AC and the length from CB? What do I know?
AC plus CB equals AB.
Okay, we do know that. AC plus CB does equal, oops, does equal AB, okay? What do we know about AC and AB? Anything about AC and CB? Yes, you add them together and they do equal AB, the length. I agree with that. What else do we know?
Well, they're the exact same.
They're exactly the same. AC is equal to CB, okay? We call that, when they're exactly the same, okay, we call it congruent. Now congruent is, I shouldn't say they're exactly the same because that would be the same point. Congruent is actually when you have the exact same measure. Two different things have the same shape and measure. Okay, so congruent is when, and the sign for congruency is this. It's got a like approximation or a squiggly line and then two the same. That means that it's two different shapes that are the same size. So here it's a line segment that's congruent to the line segment. So that's what congruent means. Congruent means they're identical except for they're not the same piece. They're two different pieces, okay? But they're identical in size and shape. One thing that comes out of this, which is kind of evident, how many midpoints are there of a line segment?
One.
One. How many rays are that bisect an angle?
Two.
Really? Is there two rays that bisect one angle? Let's think about it. Here's my angle. We're going to call my angle ABC. Okay, B, C. I put one angle in that bisects it. How many are there? Are there two or three or four or five different angles that bisect it? I want to cut it in half. There's just exactly one ray. One ray only bisects the angle A, B, C. Okay? So there's only one ray. If I put in a different one, it would be right on top if it had to bisect. So it would be the exact same one. Okay? If it bisects, what can you tell me about ABD and angle DBC? What do you know about ADB and DBC? If it bisects it, yes.
If you add them together, they equal ABC.
Yes, they do. If I add them together, this is a true statement. Angle ABD plus angle AD. This is the betweenness theorem equals angle ABC. What else do I know about those? If it bisects it, what do we know about them? Yes.
That they are congruent.
They are congruent because they're exactly the same size and shape. Okay? This is an angle, this is an angle. They're the exact same size and the same shape because they're both angles. Okay? So we can say that these are congruent. Okay? They're not identical because they're two different things, but they're congruent, meaning they're the exact shape. As we get farther on this, we have to start matching up the letters. But if we look at this, A can match with D, B, of course, matches, and D can match with C because those are the same position on the different angles. Okay, you could have written that a little differently, and it still would be congruent, because with an angle, it doesn't matter which way you name it. They're both gonna be, as long as you've got the vertex in the middle, it doesn't matter. Okay. So that's something, and so one thing we know is that there's only one ray that bisects. There's only one point that is the midpoint. Those are things that we can assume just based on the fact that if we bisect something, cut something in half, we don't have many different things that cut it in half. We know that. Okay? We know that from experience. We don't cut something in half at many different places. That doesn't cut it in half. We only can have one spot we can cut it in half at. Okay? So that's basically what 3-4 was about. And now we're doing 3-5. So make your notes on 3-5. Am I seeing everybody write some notes down? Okay, 3-5 is about complementary and supplementary angles. Okay, two different kinds of pairs of angles. Okay. Does anybody remember from previous courses or from looking in the book, because you took notes, what does complementary angles mean? What does that mean? Anybody have any idea? There's a special thing about their measurement. What?
Oh.
Yes.
If two angles are complementary, their sum is 90 degrees.
Yes, the sum of two angles equals 90 degrees. That's complementary.
And supplementary would be 180 degrees.
Yes. So basically, if you can find two angles that add up to 90, they are called complements of one another. They're complementary angles. Okay. The way I remember this, because it's hard to remember, I have all sorts of different little tricks I use to remember. C comes before S, so complementary, supplementary. C comes before S. 90 is smaller than 180, so that way I can kind of remember, because C comes before S, 90 comes before 180. That's how I remember which one's 90, which one's 180. I'm just trying to give you some tricks, because you have to try to help yourself remember what they are. Okay? Complementary is not something we use. We say we give a compliment to people. Not the same thing here. Okay? It's different than a compliment when you tell somebody, oh, you did a good job. That's a compliment. That doesn't mean 90 degrees. Supplement. We take supplements. Anybody here take supplements? Vitamins? Anybody take vitamins?
Just Scurvy.
Yeah, okay, some people take vitamins, those are supplements. That is not what we're talking about here. Those are vitamins and stuff that you take. This is 180 degrees. Our language is filled with the same words used different ways, and so it can be very confusing. Okay, so whatever helps you remember makes a good one. Okay, so basically, okay, this is another one that they give you in here, is if I have this angle, and then I have this angle, and this is A, B, C here, and we flipped it over and we made this A, B, C. That means that this angle is complementary. So this angle A, B, D, whoops, is complement of, this is very obvious, but you have to write it down, of angle ABD is the complement of angle CBA. Okay, do great. AB, oh, I didn't write the D here, it makes a difference. Okay. This one, this is a right angle. CBD is a right angle. This angle and this angle are complements because they add up to 90. Okay? So if I redraw it and I have ABC here and I put E here, then I also know that angle EBA is complement of ABC. Let's just name it as CBA. Okay. If this one is complement to CBA and this one is a complement of CBA, what do I know about EBA and ADE? What do I know about these two? If they're both complementary with the same angle, what do I know about those individual angles?
They are the same.
They're the same. Then EBA is congruent to ABD because they are going to be the same measure. Okay, does that make sense? They're going to be the exact same size. They're both an angle, so they are supplementary, or they're congruent. So we can conclude if this is complement and this is a complement, then they are congruent. So this one is congruent to this one. Oops, I wrote the wrong thing there. This is D. Sorry about that. No wonder that might confuse you. Okay, so if both of them are complementary to the same angle, this is really what you're saying. If both are complementary to the same angle, then they are congruent. Do you think that also works, I can't spell. Do you think that also works with supplementary? If two angles are supplementary to the same angle, are they also congruent? Yes. Okay. So you could say the same thing and say supplementary, and these dots mean I'm just repeating all that's above. Okay, so if both are supplementary to the same angle, then they are congruent. So that's just something we can predict. Okay, so we're really looking, because we're going to start talking about how do I find equal measures, how do I figure out what measures equal. So we have to start realizing these things are true. Okay, and then we can use those things. So we're getting the foundation for why we can say different things are true. We're stating kind of the obvious. Okay, sometimes it's very obvious. If I know that ABD adds up with CDA, then and they equal 90 and the other ones equal 90, we know the two have to be the same. So it's stating the obvious, but it's just putting it into words. Then we can use it. If we know that's always true, then we can say, okay, with certainty I know this is true. okay? And that's what they're setting up, is they're setting up the reasons why we can use these. Okay, and so that's the whole idea is, and it's defining terms, okay? So if you go into a court case, and think about this, geometry and the proofs are kind of like a court case. You can't go in and just say this is true if you have no basis for it, okay? Yes, you may try to do that, but if you have no things that back it up, we have to make an assumption about things, and we have to be very clear on what our terms mean. So that's what we're doing right now, is we're making definitions of terms. So everybody, everywhere, does geometry the same. They are always considering the same basic reasons that are there. Okay? And so in a court case, if you were going in and working on a court case, you need to have some facts, some things and definitions that are agreed upon. Okay, what is the definition of a second-degree rape? Has to be very clearly specified. And if it's not proven that that was what occurred, then you can't convict them. Okay, so that's something that's the idea behind all of these definitions, all of these things that we're saying are true. Okay, so that is the end of what we talk about in these two sections.